Hi all, this is Argo from the workshop Data Science for All. So I am recording this supplementary video to teach you about Pandas characteristics, introduction to Pandas. Because of some time mismanagement, we could not cover the entire part of Pandas that we thought to, and that's why I'm just making this separate video and will share with you so that you can go over it in your free time and learn it at your own pace according to your convenient time. So let me share my screen over here and I will start from where I stopped. But just to give you a little bit of just to make the symmetry, let me discuss what you have seen in the previous video. I mean, in the workshop. In the workshop, I have showed you like how to install pandas, like using this pip command. But as I mentioned earlier, in Google Colab, everything is already installed, so you really do not need to do that. But as many times you will open a new session in Google Colab, you have to run this import pandas as PD. So let me run this once again, and it will import the entire pandas module in this PD variable for this particular session that I'm going to record now. And well, in the workshop, I have discussed like how we can convert a dictionary like this into pandas data frame, something like this, and utilizing this data frame function. So just pd dot data frame and pass the entire dictionary and it will convert it to data frame basically. So if I just run this thing, you will see that, well, the df is this dictionary data have been converted to a data frame, and it is a fancy looking display for the data frame. So data frame is basically a table. And not only that, we have discussed that how you can convert a NumPy array to pandas data frame, or pandas data frame to NumPy array, vice versa, like that. So this this data frame function can not only take dictionary, but it can take any type of array, like this my array, which is basically a NumPy array, a two-dimensional NumPy array, as you can see in this line. And it has converted it to a data frame called df, where you can specify the column name like this, column A, B, C, and it will just convert it to pandas data frame. So let me just comment out the last three lines to focus on like how it is converting to df. So as you can see, it is column A, column B, and column C, user defined column name over here, and this entire NumPy array have been converted to a data frame. Now if you just type this df in this Google Colab, it will do like it will give you a very fancy looking display, and you may want to go with it. So it's up to you whether you will use print df or df, whatever you find useful. So but anyway, for a Python program, a batch Python program, you have to use this print command, and that's why I am using print command in my code, so that you can directly download the Python file using this file, then download, and then this download.py, and you can run it. So anyway, it's up to you, by the way. And well, the second part is basically how to convert the data frame to NumPy array using this to NumPy function. So data frame df is like this now, and then it is I have just used this to NumPy and storing this NumPy in the array inside an array called n array. So if I just run this program and if I print this type of n array, I will see that, well, this part is not a data frame anymore. It is a NumPy array, as you can understand through this opening and closing box brackets. And also you can see that the type have been changed to NumPy ND array. All right, so this is how we can change between pandas and NumPy. Uh, and the most important part, as I have told, Pandas is not for this type of hard-coded data reading or something like that. Pandas is made for big data processing. And most of the time, the data sets are available through a file, either a CSV file or a JSON file or something like that. And as I have told, that I have made a file available publicly through my Google Drive, which is basically Wisconsin's breast cancer data, where there are lots of different, where everything has lots of different columns are there, like as you can see in here, A, B, C, D. Every column has its own name. As you can see in here, the first row is basically the heading of each of the column, the names, and then there are many records, as you can see in here. So so this is a breast cancer dataset that we are going to use, and these datasets is still available over publicly. You can use that, or if you want to make your own dataset, download it and then follow these steps. Basically just follow these instruction and you can create your own file basically to do that. So anyway, I am just going to use this box, but just for your future reference, if you want to make your own file and test it, you can use all these different comments. For example, if you want to copy it to your local machine, you can just download the file and then use this file path and then start running your Pandas code. Or if you want to read it through your Google Drive, let's say you downloaded the file and then upload it to your Google Drive, you can use this piece of code. Just make sure to read these comment and you will be successfully able to read this. But anyway, let me stick to only this first part, like the publicly available data. You can also use it. So here, as you can see now, this DF cancer is basically a data frame, and by using this read CSV function from command and this file URL, which is basically the web URL of this entire file, I just read the entire data into DF cancer, which means like data frame cancer, and then just display it as DF cancer, and I got the display here. So now let me show you some of the different exploration of data exploration, which is basically the first part of any data management project or data science project. So here basically, in order to explore the data, just I will rerun this command once again because just I wanted to avoid this scrolling, but you can do it accordingly. I mean, you can just skip this step. But this step is basically the same step that I have written earlier. And all right, so now here, let's say if I want to get some statistics of the data set, then what I can do is I can use this .info function. So if I just do like this, you will get that, well, there are like 570 data points are there for each of these column. You will get all the column names over like this, and how many values are there in that column. So right now this file has like 31 different columns. These are all the column names, and these are the total number of values that are available, and how many non-null values are there, that is basically given. And also you can see the data type of this variable. So these malignant and benign, as you can see, they are basically M and B written over here. If I go to the data set, this is basically the malignant and benign. So it is a character or a string. And so that's why it is simply an object. Everything else over here in this data set is basically number. All these columns are number with some decimal points, and that's why all these columns are listed as float 64, something like this. And if you see this ID column, which is the first one, that you will see that it is basically an integer. It does not have anything after decimal points, so that's why it is by default it is read as int 64. And so this is the basic statistics, what you can get by just typing this info, but just using this function. Now, if you want to get the information about one single column, then you can use this df cancer, then followed by this column name inside the opening and closing box bracket inside quotation, single quote, and then dot describe. So if I just run it, let me show you what happens. So it basically gives the statistics regarding this ID column, means how many total number of counts, total, I mean, mean, standard deviation, and all the different statistics are given. So let's see how it changes if I just change, this ID is basically an int 64 column, as we have just discussed. But now if I just change it to this column, so let me just copy paste this name over here, and let me paste it here. So, and also, of course, I have to put it inside this single quote or double quote, whatever. Let's see what happened. So here, as you can see, since this is not a integer or floating point type of thumb, now it is not a numeric column, it's just a string. That's why it is just giving 570 count. Unique is how many different unique string are there. So right now it has only M or B, so that is why it is B. And how many, which is the most common string, like top, all these different things are there. And of course the top's frequency is also given, how many times this top string have been occurred in here. And so like that. And so numeric and categorical things, or this string object type of things, those are automatically taken care of, as you can see in here. So also there are several other columns to get some more information about pandas. Or for example, like if you just use this dot columns attribute, it will show you the name of all the columns and whatever, I mean, the first rows, all these things you can see in here. And also there is a function called length, which basically can give you the total number of columns, how many columns are there. Basically, when you are writing this df cancer.columns, it is basically creating a list in Python that we have discussed in the workshop. And then list basically has a len function which gives the length of the list. So this is a list of the string where each string represents a column name, and total 32 names are there, because 32 column names are there anyway. Next is there is a shape function just like numpy, and if you just run it, if you just run it, you can see what is the shape of this function, and like so. So right now it has 570 different rows and 32 different columns. That's what it is saying. And also, if you want to display the first 2 rows or first n rows, you can always use this head and then specify how many rows you want to check, and it will give you those many rows. So I want to see 2 rows, so it gave me 2 rows over here. And also, if you want to see the last 2 rows or something like that, you have to just use this tail function, and then you have to pass how many rows you want to see. So if I want to see last 2 rows, I just use this like this way, tail n, and like so. And it is giving me the 568th row and 569th row. And here this head gave me 0 and 1 row. So that is one functionality of head and tail. Then there is a functionality called if you want to check how many null values are there, the total number of null values. So but before, if you want to check the total number of null values, you can always use this like df cancer, the data frame name, then is null is the function which is checking whether there is any null or not. And then there is a sum, which is basically checking which is just accumulating all the null values and giving you the number. So for each of the column, so it means that ID column has 0 null value, no null values are there. Diagnosis, the next column, has no null values. So basically in this entire data set, there is no null values. It is saying that. And also if you just do this is null, what it basically does is checks each of the cell if there is a null. So if you just run this, you will see that there is a sequence of true and false, this type of Boolean values. What it is basically saying, if it is a null, then it will print true, means it is null, it will print true. If it is not null, it will print false. So it is like that. And then when you are doing this dot sum, what I have just shown, it will basically calculate the total number of true that it has found in this entire data set. I mean, sorry, in each of these column of this entire data set. So that's what it is doing. So now let me just go ahead and change this, and let's see whether it is changing anything or not. So let me just add the first one. Let's delete this first value over here, and let's say this ID, the first value, is null now, and this texture also, let's change it to null. So ID and texture, I introduced some two null values intentionally. And now let's wait for a few seconds to see if everything is reflected or not. And now let me run it once again over here. Well, now since I have changed the original data set, what I have to do, I basically have to read the data frame once again, because I have changed it. But right now in this Google Colab session, it is holding the previous version of the data frame, not with this, with all the non-null values. So let me read that once again over here. And as you can see, now everything is updated. So this one is appearing as nan, I mean null, and this one is also null, the two places where we have deleted all these things. And now let me go to that part where I just checked all these things, so whether it is null or not. So let me show you what is happening over here. So now if I just run this thing, you'll see that since the first one is null, it is printing true here, and this is also printing true over here. So now which is expected. And if I just want to check the sum, how many null values are there, you will see that, well, now it has one null value over here in ID, and in texture also there is one null value. So this is how it works. So this is null function is very important. Sometimes you may have missing values in your data, and if you want to check how many missing values are there, and you can use this. Based on that, you can take your decision that how you want to pre-process it. And also there is another function called duplicated. And now if I just do this, you will see that it will basically check how many duplicated rows are there. The entire row is duplicated or not. Now, right now there is not many duplicated, but let me show you. I think there I have already installed, I have already introduced a duplicated row. But anyway, let me show you how the number is changing. So, but before that, let me just get back to the previous the original version of the data frame, just to avoid any type of confusion. And now let me just copy this and copy this row number here, the first row over here, and let me insert a row above, and then just let me paste it. So here now this row number 2 and row number 3 is of course duplicated. As you can see, I just copy pasted the row. And now let's see how it changes. And so once again, since I have made changes in the original data in Google Colab, I have to read the data frame once again in Pandas. So let's see whether it is reading properly or not. So let's read it once again. Well, it's still not reflected because still now it is showing the null value. So let me just check it after a few moments. And if I run it now, let's see. Well, so now it is everything is good. And now, as you can see, this row, these first two rows are basically duplicated over here. And now let's see what happened to this duplication function. So here, basically, if I come here and if I just run this, then you will see that the row number 1 is duplicated, which I have just copy pasted. All right, and also the length of the rows have been incremented by 1, that is 571. Now let's see if, and once again, just like this sum will basically calculate how many duplicated rows are there in your function. So let's say like this, and over here, and if I just run it, we'll see that there are 2 duplicated rows are there basically. So possibly I have added another duplicated row during the workshop session, which is showing also here. Now, well, you really do not need to guess how many duplicated rows I have introduced or what is it. You can see where the duplicated rows are there. So here, basically, this is again like if you want to check where the duplicated rows are there, what you have to do, you have to use first this df cancer, and this opening and closing box bracket means that, all right, I'm considering this entire data frame. And then inside that, you can write your own query. Here, the query means you are just checking whether df.cancer has some duplicated rows or not. Just this exact line, which is basically giving you whether there is true or false values we just checked, right? So now if I just do it, it will just print all the places, all the rows where the value is true. So just to give you show you once again, if I just run this df.cancer.duplicated, as you can see, this number 1 is showing true. Possibly there is another true in between somewhere, but it is not visible right now. But anyway, we are going to check it now. So these true values, wherever it will be true, it will be displayed over here. And as you can see, row number 1 is duplicated. So row number 0 and row number 1, that is duplicated. And also row number 7 is duplicated. So let's see whether these are really duplicated or not. So this row is of course duplicated. I just copy pasted. And now row number 7, as you can see, well, yes, this is row number 7 and 8 are also possibly so I have to check it once again. What happened? This 843786. So let's see whether this ID is duplicated or not. So over here, let's say Command F, and let me check by finding. So, well, yes. So, okay. So, all right. So 7 was because it was starting from 0, and actually it is appearing at 8 and 9. So that's why, as you can see, both these rows are basically duplicated, and that's why it is giving me duplicated rows. So this is how you can gather several statistics and several information about your data frame. But anyway, now, so after gathering all these statistics, now it is the time to pre-process the data. So if I just, so let's focus on that. Now, once again, I will just simply run this thing in order to avoid scrolling up and scrolling down. But before that, let me change it, revert it back, revert this entire data set back to its original state. So let me delete this duplicated row over here, and also let me delete this duplicated row over here. So delete row. All right, so now there is no duplication, and let me just save it over here. And now let me run it once again. And well, still it is not reflected. As you can see, it is still duplicated. It should not. So let's wait for a few seconds and now run it once again. And let's see whether, yeah, now the duplications have been removed as we have done over here. So that is how. So now I just read this data once again in our Google Colab context, and DF Cancer is now the original dataset that we have started with. And well, so now if I want to, so I have shown you how to detect the duplicate, how to detect the is null function. Now, how can you remove the duplicate? That's the pre-processing part. After gathering the statistics or after gathering the knowledge about data, now you have to pre-process the data according to like that. So now let's try to delete the duplicates. What you can do is you can always use this drop duplicates function. Now here what you can do, well, I think it will be better if I just add the duplications once again over here, and let's because that way you can easily understand it. So again, I have just intentionally added these two duplicated lines over here. Let me read it, and let's see whether, okay, still it did not read properly. So let's wait a few seconds and let's read that. Well, it is taking longer than expected. So anyway, let's see. All right, now it is read properly. The first two rows are again duplicated. And now we need to drop this duplication. So there is a function called drop duplicates. And then there is something called in place equals true. So let me first show what happens if I do not use this in place equals true. So if I just run this, you'll see that although I have dropped the duplicates, it is not reflected in this data frame. So basically what it does is it basically creates an entirely new data frame without any duplication. So that's basically just a copy. It is not reflected in place. So if you want to do like that, you have to do like a DF cancer 2 or something like that. Now, if you just run this now, then you will see that, well, this new data frame which you have stored, it does not have any duplication. But this one, the original data frame that you have created, it still has the duplication because you did not use in place. Now, if you just use in place over here, then you really do not need to store it anywhere else. Now, if you run it, you will check that, well, the original data frame DF cancer do not have any duplicate because everything is removed. Now, always remember, to remove the duplicates from the in-memory data frame means this place. It did not remove the data place data in the file. File is intact. So it basically read the entire file as an instance in the memory and then dropped everything. So this is how you can remove the duplicates. And similarly, there is a function called drop NA, like this drop duplicates, drop NA, that will basically remove all the null values. If there is any null values in this data frame, it will drop it. So currently, I do not have any null values, but if you are interested, you can check at any point as just a small self-evaluation homework, that whether you have understood or not. But anyway, if there is any drop, if there are any missing values, it can delete all these those null values basically. Now, now, well, one more thing that I would like to tell you about these null values. Let me show you null values actually. So let's let me just enter one null value over here. So let me remove this duplication now, or let me just add a null value over here, this ID, and then let's say this texture. And then let me save it, and let's read it again. And like in here, in this pre-process phase, I am reading this data once again. And as you can see now, the first row ID and first row texture, they do not have anything. So all are null value. So if you want to drop these null values, then you can use this drop na, and that's true. So now let's see what happened over here. So if I just print this df cancer after dropping these null values, there you will see that, well, if I run it, as you can see, the entire row where the null value appeared, it have been deleted. So that's one thing you have to remember. So if you do not specify, do not explicitly say what you need to do with these null values, you can, this drop now function will remove the entire row which has null values. So let's say if you have null values over here, or let's say if you have null values over here, if you have null values over here, so that will delete all those rows which have null values. Okay, so like that. And now if sometimes, let's say it may happen like let's say many of the, instead of sometimes it may happen, let's say one of the column is does not have too much value. So for example, let's say this radius, okay, so it does not have many of these values. Let's assume that these values are totally not there. So what will happen now? Just because of one single row, I mean, sorry, just because of one single attribute is missing in all the records, all these rows will be eliminated, which is not good, right? So that's when what you need to do is you have to specify the columns. So let's say you have to write down like axis equals 0. All right, so axis equals 0 means, so let's see what happened, and let me read the data frame once again. And well, if you just drop this column now like this, now you will see that well, so this is axis 0, and if I do like this axis 1, then you will see that, well, this call, oh, okay, so yeah, so in place, and this axis 1 will basically delete this entire column. So let me see what happened actually. So it was supposed to delete this entire column like this, and in here, and then let's say if I just do this, and well, now, so it was not reflected possibly. So now, as you can see, instead of deleting the entire row, it basically deleted the entire ID column. So if you just write down like this axis 1, it will basically delete the entire column for you instead of row. But it totally depends on your data characteristics. If you have some, only a few missing value in some places scattered around, it is always a better practice to remove some of those records. Let's say you have 1 million data points and 10 of them have missing values, so it is always good to remove the records. But sometimes, let's say you have 1 million data points and only 100 data points have some specific column value, but everything else is null. It is always a good practice to remove that column instead of that row. So this totally depends on you, and just by changing this axis value over here either to 0 or 1, you can remove the rows or columns of the data frame. But once again, it is not removing in this actual space, actual file. It will just remove in the data frame. So let me just change it back to the original value so that to avoid some confusion. And let me just read this pre-processing part once again, and possibly it will take a little bit of time. Let's see whether all the null, yeah. So now everything is removed. So all the data frames are, everything is good now. So like that. And now let me, and also, well, I think I have one duplicate which was not there in the original data set. So let me remove that also, delete row. So now everything is original data set by now. And so in order to do that, once again, so whenever I am making change in the data file, I have to read that once again in this Google Colab context. So let's see whether it still did not remove the data file. I mean duplication. It is not reflected. So let's wait for a few seconds, and now let's run it. And the data duplication have been removed, and it is the original file that we have started with. So anyway, so these are all the functions that we have just discussed. And now let me show you some of the, so this is how you can do some of the pre-processing of the data. And not only that, sometimes it is required, like, okay, you want to change the column names. Sometimes it is very important because you want to use your own column name. It is very common when there is no standard practice for data sets and you want to merge several data sets from several different sources. They are all similar characteristics, but because of lack of terminology related standard, they all have different names. So what are you going to do at that point? Of course, first you will merge all the data points or something, and then basically you need to change these column names. So here is how you can change the column names. So for example, here the first thing, it was %id. I want to change it from %id to just id. Then diagnosis, M malignant, M B benign. I just want to make it just diagnosis. So this is the syntax. You can use this rename function, and then this inside this parenthesis, columns equals, and then this inside this opening and closing curly brace, you just change the original name followed by ID. Just think of it as a dictionary where the key in the left hand side is the current name of the file, current name of the column, and the right hand side, the value is basically what you want to do. So what it basically does is it search for this key, that is the actual column name, and replace it with the current value of this dictionary. That's all it does. So just to give you what is what is happening in the background. But anyway, as a data scientist, you really do not need to know that. This is just the function. But once again, here also you have to use in place equals true, because otherwise it will not work. Every time if you want to make change in the actual data frame, this df cancer, you have to use this in place. Otherwise it will just make a separate copy and change there. All right, so that is how you can do some of the data processing, remove duplication, remove null values, changing the columns, etc., etc. And now let's see some basic mathematics and statistics on data frame or series. So, well, first of all, this Pandas is basically developed on top of the Numpy. So all the functionality that works with Numpy that we have discussed in the workshop, they all works in Pandas, almost in the same fashion. So if you want to get the mean, means the average of all the columns, which is sometimes very important to normalize the data or standardize the data or to get some knowledge, you just use this mean function over here. And so nowadays, basically, you have to mention like numeric only equals true, which means it will just do the calculation on the numeric columns. Otherwise, there will be some performance glitches. If there are lots of categorical values like this M and B, they will also be calculated and there will be some errors, and Panda will manage the errors internally, eventually resulting in a performance issues. So it is always a good practice to write down this numeric only equals true. So if I just run this, you will see that, well, ID has the column mean is this one, and radius has mean of this, like so. And one thing you should notice that we have changed the name of ID over here, and that's why it is appearing as just ID instead of percentage ID. And like that. And so in this way you have to do that. This is for mean, and also well, all right, now this is to get the mean of all the different columns. Now sometimes you may want to get the mean for one specific column, let's say this radius column. If you want to do that, just use this df cancer, the data frame name, and inside this opening and closing box bracket, just use this column name inside quotation. So always, whenever you will use this want to access some column, put the name inside this opening and closing quotation symbol. Otherwise, it will be taken as a variable and it will give you some weird result and end up in error. Sorry. So this is how this radius column mean you can get just a particular column. And well, the same way you can calculate the max in here. If you want to do that, you will see that what are the maximum value of each column of the data set. And if you want to check it for one single column, just use this the same syntax, but this max function, like so. And the similar way you can do it for the minimum to find the minimum. And so like that way you can do all these things, I think. Okay, so this one should be the standard deviation, so it should be STD, and it should not be mean because I want to show you the standard deviation. So well, the best way to learn about it is just put a dot over here, wait for a few seconds, and it will give you all the functionalities that are available on this function. And if the function names are very intuitive, if it always like same as our mathematical concept. So whenever you will get some kind of mathematical names over here, and you can always just try those functions to get all these maths or stats related things. It's very much intuitive in nature. So just by checking the name, you can understand what type of mathematical function, mathematical operation it is doing. So anyway, so like this, and well, I think this line should go over here, std. So before sharing this, let me delete this piece of code. So this is a standard deviation anyway. So there was some mean and standard deviation related problem. I just changed the name over here, but anyway, it's similar. So that is it. And now the last part is, well, so we have learned how to read the data set from data frame from a file, then pre-processing, get some information about the file or the data frame, then pre-process that data utilizing some pandas function. Now the last part is how to filter a query, filter or do some query in the data frame. So the first thing is, it is basically a particular, if you want to access it, you have to use this I@. Function over here. So if you just want to access the function by row name and column name, then I mean the column number, then you have to use this I@. Function. Sometimes the dataset may not have any column number given, I mean column name given, then you can use this row and column and it will give you get you to that row. It's just exactly like Numpy. And then let's say if you want to get the data in a specific column, then you can use this type of name, this type of syntax actually. So it will give you the column name is area and what is the 2th row, what is happening in there. So 1203, if you go to the original data set over here, you will see that, well, this is area column. So over here, there should be something like this area column over here. Let me search area over here, and area will start from 0, 1, and 2. 2 is 1203, and you got 1203 over here. And if you do like this type this way, let me see whether it works or not. And because this is how you use in Numpy, so if you just do that, then it will give you an error. So if you want to access a particular row for a particular column, then you have to use this syntax always. So pandas, sometimes pandas syntax a little bit weird sometimes. There are some reasons, but anyway, just be careful about these. And anyway, so the other points that you need to remember to do some data analysis, that this only writing df and then df followed by 2 sets of opening and closing box bracket. They refers to the same thing. But just by writing df, you cannot do any type of query. In order to do any type of query, you have to always use this syntax and then write the query in between this box bracket. That's what the thought is. So like that way. And so now let's see what we want to do. And this is another points to remember, that one single box bracket denotes a series, but 2 pairs of box bracket basically denotes a data frame. So here, as you can see, like these, let's see what happened. Key error ID. Okay, so I have changed the name from %ID to ID, right, earlier. So that's why you have to use just ID over here. So it gave ID. And anyway, I am just changing it to %ID so that when you will get this IPy-NB, you really do not need to make any change. So anyway, so as you can see here, I have used one single box bracket. That's why it is a series. And here I have used 2 box bracket. That's why it is a data frame. That's it. That is very important. And many, I know many of them, and I am also not an exception. When I started working with pandas, this was a very big source of confusion. When we will use this double box bracket and when single box bracket, like that. So always remember this concept. And after that, let's say now let's say if I want to do some kind of let's say if I want to do like print some different columns, not the entire data frame, but I want to print some different columns. So here, let's say the column names are diagnosis and then area and these concave points, all these 3 columns I want to print. Now, always remember that this one is a data frame, one single bracket. So inside the data frame, 3 columns does not make any sense, because series means it is this one box bracket means it is a series. Now inside a series, 3 columns does not make any sense. So because series means just 1 column. So if you just want to run this line of code, it will give you an error because it is series. But if you want to display it as a data frame, then it is all good. So here in this line, let's see what happened. Well, we have changed these to diagnosis, I think. So let me just see whether, or it may happen like we have just, so like this. So now everything is okay. If you can remember earlier, we have changed the name, renamed it from diagnosis to the entire name. We changed to diagnosis in this part, basically using this rename function. And this is why every time I need to use this diagnosis or ID instead of the entire column name. But anyway, I am going to change it to the original column name once again after running this code properly, because so that you do not have any confusion after you try to run this code. So that's it. Next is let's say once again I have to change this name. So now let's do some kind of like Boolean search. Let's say so this is where we are displaying all the rows in these 3 or 4 different columns. Now let us try to do some Boolean search, which is again similar to this Numpy, what we have seen during the workshop time. So once again, let me change this name from this entire name to diagnosis. And what I am doing in here is, let's say the first one, like in here. So what I am doing here is, let's say I want to see those rows where all the diagnoses are M. M stands for malignant. So if I just do that, then you will see that, well, I am seeing all the records, all the columns where the second row means this diagnosis column has the value M over here, and it has 212 rows, and the entire data set has 32 columns. So that's it. Next is and now once again here, just see what I am doing over here. Now this is basically one set of box bracket, and inside this box bracket I am writing this Boolean example. Once again, what it is doing is, in that column, whenever this condition is satisfied, in that column it is always writing this true, false, or something like that. Whenever the column is satisfied, it is true, this condition is satisfied, it is replacing it with true always. And after that, whenever we are writing this df cancer and then enclosing that condition, it is printing all the rows where the value is true. Anyway, so that's how it does all the searches. And after that, let's say if I want to do some more searches, we want to see that, well, the column name is male, that's okay, but also this column name 3 means these concave points are less than 0.7074. So if I just do that, here also this relational operator, this AND works. So if I just run it, you'll see that now we are seeing these 73 rows where every diagnosis is M, and this column name 3 means concave, which is less than 0.074, like that. And so this is how you can do that, and conjugated the condition. And finally, the last thing, and last but not the least, what we are doing here, let's say sometimes you may need to print out only a few columns where the condition is satisfied, not the entire data frame. So here is how I have shown you how we can filter the rows by using this condition. And previously in here, I have showed you how we can type only a few columns, not the entire data frame, all the columns. So now let's just club it together. So what we are doing here is the first part, df cancer, and until this part is exactly same as the previous line, which is basically doing the search part, and it get the entire data over here, or entire data. And then there is a second part which is saying that, well, let us display it as a data frame and display only this column name 1, column name 2, and column name 3, nothing else. So if I just run this, then you will see that, well, the entire data frame, all the columns are not displayed, only these columns are displayed. So this is what we wanted to cover during the workshop hours, but we could not cover it. So please go over this video, and if you have any type of trouble, feel free to reach me out at my email ID, akdas@alaska.edu, and I'll be happy to answer. Thank you.